Hello, everyone. Okay, I said that I was going to post a video, and I want to do that. So I want to go pretty fast because, again, this could take a really long time if I went slow. So what I did was, in a lot of the problems where there are two of the same, I posted one and then just left the other one answered. And you can pause it if you'd like and look at the process that I used to solve it. But anyways, there's going to be other problems like this one where there's really no reason for me to go through and explain all of these because we have explained them so many times. So I just left the domain and the range posted here. Don't forget, and I don't want to do this with every one of them. Domain means what connects B. So, for example, on this line, it never stops going down and left. It never stops going up and right. So the fact that it never stops going left and it never stops going right, that's what makes the domain uh, negative infinity to positive infinity. Range, same thing. Never stops going down, never stops going up. So negative infinity to positive infinity. So go back and look at those if you've forgotten them. But I've posted the domain and ranges for all of these. So here they all are. Again, if you need to ever pause a video to see something, go ahead and do that. But I'm not going to linger on here long because I don't want the video to last too long. Okay, and then I felt the same way about numbers 1 through 6. You can look at the graphs above and you can tell which one these are. The only two that I would say are maybe a little tricky would be number 2 and 5. Because if you look at a cubic function in its basic form, it doesn't go up and then down and then up. But 2 and 5 are both cubic because you can tell the shape, how they do kind of have that same move. But because of the different transformations that those graphs have had, it makes that transition a little more pronounced than the original when there's nothing that's been done to it. So that's why 2 and 5 look a little bit different, but they are both cubic. Okay, transformations, again, something you guys should be relatively familiar with. So remember, there were four major transformations. Well, kind of three. There were shifting, and the two shifting are shifting inside and shifting outside. Shifting inside meant left and right. Remember, on the inside, it was the opposite. If it looked positive, it actually went left. If it looks negative, it actually went right. But then there was also shifting on the outside. It was what it was, so it shifts up if it's positive, and it shifts down if it's negative. And then, of course, you had reflections. That was the third type of transformations. If it's negative on the outside of whatever your parentheses are or absolute value bars, whatever it might be, then, of course, it reflects vertically. And vertically means over the x-axis. Where inside it reflects horizontally, you wouldn't see that reflection as much for most of the graphs, but it would reflect over the y-axis. And then, of course, you had your last one was your dilations, where it would actually stretch or compress. And we're only dealing with the ones on the outside. So those would be vertical stretches if the value is greater than 1, and they would be vertical compressions if that value is less than 1 or between 0 and 1. So let's go ahead and name some of these. And again, like I said, we're going to go pretty fast because if I didn't, this video would be tremendously long, and I don't want that. So here we go. Look, we are adding inside. So remember how that works? That's the opposite. So it's actually going to shift left 3. Okay, here there's a negative on the outside. So that's going to be a reflection, and it's going to be a vertical reflection. So it's going to reflect over x-axis. Number 9, we're multiplying by a value between 0 and 1. So it's going to get wider. So that's a vertical compression. Directly below that, look, we're multiplying by a number greater than 1. So that one's definitely going to get more narrow, and it's going to be a vertical stretch. We'll just keep working back this way. Again, I'm adding outside. That's a vertical shift. It is what it is. So this is going to shift up 3. And then last one, we're subtracting on the inside. So this is going to be horizontal. And remember how that works on the inside? It's the opposite. So that looks like a -5. So it's actually going to shift positively to the right. So it's going to shift right 5. All right. And that, again, is what you're going to see on the test. So should be a really simple portion of the test to deal with these transformations. Okay, number 13. We're supposed to pick multiple choice. Which of these have been vertically compressed? Okay, so remember, vertically compressed means the value has to be between 0 and 1. So that knocks these two out. So we're between C and D now. It's shifted 3 units left. Now remember, left 3, on the inside, it's going to be the opposite. So when I think of left 3, I think -3. But it's going to be the opposite, so it's going to be +3. And then, of course, down 8, they're both. So the answer here is C. Very simple. And you're going to have those on the test. Again, this is the same thing. I've left your answer. It's upside down. There's the negative. -2, remember, that's horizontal shift. So it's going to be the opposite. So +2 inside. And then it went up 4, so it is what it is. So B. Number 15. This one is asking about the range. So what I like to do is I like to just picture the graph. This one is positive, right? It's positive. So it's going to be opened up. It's a quadratic, so it's going to be a parabola. And my, sorry, I got a phone call. I was checking real quick. My vertex changed. It went right 4, down 1. So if I'm trying to picture this on a coordinate plane, it went right 4, down 1. So this thing is like doing this number. So it asks about the range. Well, remember, range is what y could equal. Well, y can be everything from this y value right here and up. So what was that y value right here? Well, the point was at 4, that's x, -1. There it is. So this thing's going to range from -1 and up forever. So that's from 1 to positive infinity. I'm sorry, not positive 1. That's -1 to positive infinity. D. You can see the same thing done on 6. Again, pause it if you need to, but I'm going to keep moving. Okay, remember vertex is your H and your K. So my H here is found right there. Remember, it's the opposite. So my vertex is going to be -3. And then Y, our K value is what it is, so +2. All right, let's look at the next one on our graph. I'm just going to type this in, and then we'll come back and look at what this is saying. So I'm going to type in x minus 2, close parenthesis, open parenthesis, x minus 5 squared. And I'm going to look at this graph. If you notice, it goes through the x-axis at 2. That's one of my zeros. But it also comes down and it touches it right here at 5. And then it goes back up. So my zeros are at 2, and then also right here at 5, 0. So look at the answers. 2, 0 is a 0, yes. But is it a minimum? No, look, it's not a minimum. That's not a valley right there. It's just going through it at 2. So that's not going to be my answer. 2, 0 is a 0 and a maximum. Definitely not a maximum either. 5, 0 is a 0 and a minimum. Look here. 5, 0 is a 0, and yes, it is a minimum. See, it's a valley. Definitely not a peak, but a valley. So 5 is a 0 and a relative minimum. So C is our answer. And A, you can see, is identical to that. Okay, let's keep on cruising. I'm going to do a couple of these on number 21. It's wanting you to substitute -2 into g of x. So every time I see x, I'm plugging -2 into it. But then don't forget, you also have this additional part of this equation where you add 4 at the end. So here's literally what I go do in my calculator. I'm going to do 3, open parentheses, -2, close parentheses squared, -2 times -2. And that's all of the g of x. And then I'm going to add 4. So that's a pretty easy thing to do. We're going to go to our calculator. We're going to type it right in, and we're going to let it spit out an answer. And I did that. You can do it too. The answer is 20. So pretty simple problem. And we've got a couple of them. There you can see 22 over there. You can see 24 all worked out. So let me do number 23. I did tell you guys to change this value to positive. So I had already made that change. I told you to change this one to positive 2. So I've already made that change. So all I got to do is solve. So here I'm going to subtract 12. Well, 96 minus 12 is 84. Then I'm going to divide by 3. So x squared will leave me 28. Now you guys know to get rid of squares, we take the square root. And when we take the square root of both sides, we have to add this answer plus or minus. It's going to be a positive and a negative. We talked about that. But I'm going to break down 28 over here, and I'm going to try to think of the biggest perfect square that goes into it. So 28 is not a perfect square. If I divide that by 2, that's 14. The first perfect square below 14 is 9. 9 will not go into it. So the next one is 4. 4 goes into it 7 times. So 4 being a perfect square gets to escape as a 2, and that 7 stays trapped inside. So plus or minus 2 square root of 7. Those will be your answers that you choose on your multiple choice test. Okay, moving along. Quadratic formula, again, is something that you guys will be given. It is on your, it might not be on the formula sheet itself, but it doesn't matter. I will have that. It will be provided to you if needed. So here is the formula. X equals negative b. Well, b is negative 10 plus or minus the square root of b squared, that's negative 10 squared, minus 4 times a, 1, times c, 15, and all of this is divided by 2 times a, 1. Again, remember, I got those values from right here. A is 1, b is negative 10, c is 15. So here we go. Let's clean it up a little bit. Minus negative is positive 10 plus or minus the square root of. I went ahead and typed this into my calculator, the underneath here, and I got 40. And of course, 2 times 1 is 2. Now over here to the side, let me make a little bit of space here. I'm going to break down 40. 40 is not a perfect square. Divided by 2, that's 20. 16 does not go into 40. 9 does not go into 40. So it's actually 4 again. 4 goes into 40 10 times. So that turns into a whole number 2. 10 gets trapped inside. So here's what we're left with. We're left with 10 plus or minus 2 square root of 10 divided by 2. So I can actually, since both of these are whole numbers and they're both divisible by 2, I'm going to go ahead and break this all the way down to this. 10 divided by 2 is 5. Plus or minus 2 divided by 2 cancel, and the square root of 10 comes on down. So 5 plus or minus the square root of 10. You can see 26 worked out over there. Pause if you need. 27, I'm going to factor this, and I'm going to factor it by getting all the terms on one side. And if you recall, when we factored these, we actually used this method called the over-under method, where I distributed that 2 to that 10. So I went x squared plus x minus 20, and that's what I focused on in my factoring. So I went, to make this easy, x times x gives me x squared. Positive times negative gives me a negative. So I was looking for the two numbers that multiplied to get 20, but had a difference of positive 1. So you could go through your factors of 20 if you'd like. You've got 1 and 20. They have a difference of 19. That's not it. 2 and 10. Those have a difference of 8. That's not it. 4 and 5 have a difference of 1. So since that positive wins the middle, we had to put the positive with the bigger factor. So that's a 5. And then we put the 4 here. But please don't forget the over under. We did the over, but now we got to do the under. So I got to come back underneath with that 2. So our two factors are actually 2x plus 5. And since this reduces, that'll be x minus 2. So I'm running out of space here. So let me do this over here. I'm going to take 2x plus 5 and set it equal to 0. I'm going to subtract 5 and then divide by 2. So that's negative 5 halves. Then I'm going to take x minus 2, set it equal to 0 and solve, add 2. So my two answers are 2 and negative 5 halves. So that's right here, B. Okay? Do remember that this is a multiple choice test, all multiple choice, no multiple selects. Every question will have one correct answer. Okay, this part was pretty easy. Remember, when you have zeros given, like this saying x equals 3 and x equals negative 2, they want the factored form. Remember, how do you turn x equals 3 into a factor? Well, you move it back to the other side. So I would subtract that 3. So the factor that would have given me the solution 3 would be x minus 3. So obviously, to give me negative 2, that's going to be x plus 2. This is the factored form. Now, very closely related to this is when we have it written as a solution set. See, these are not parentheses, they're brackets, indicating that they're both zeros. They're both solutions. So it's almost like what you see above. That's saying, hey, x equals negative 2, and it's saying that x equals positive 5. So it's identical to the one above it. It's just written differently. So my factors are x plus 2 and x minus 5. So just like we see it above, it's the same type of problem. So you might see one or both of those types on your test. So just be prepared for that. It's really easy. All right, moving along, as you can see, 34 is already done. It's done the same way as 33, where it asked me to give the axis of symmetry when it's in standard form. Well, if you don't recall, the equation to do that was x equals negative b over 2a. Remember, it gives you the x value of your vertex, which is actually your axis of symmetry. So literally all I have to do is, here's b and here's a. So I just have to go negative b divided by 2 times a. Well, that's negative 6 over 2 times negative 2 is negative 4. Well, the negatives will cancel, and 6 over 4 will reduce to 3 halves. So my axis of symmetry would actually be the vertical line x equals 3 halves. It's pretty easy. I hope that you guys understand that. Probably no problem. You see, I also did 34, so you can see that one. Let's move to the next one, which is way easier, because remember, it's the x value of my vertex. Well, it's in vertex form. It's giving you the vertex. Now remember, it's on the inside, so it's the opposite. So it's actually x equals negative 2. Okay, very simple. Those are way easier to find the axis of symmetry when it's in vertex form. Let's keep on cruising. Here we have some adding, multiplying, subtracting polynomials. So very simple. I'm just going to knock these out without even talking too much. I got 3x squared minus 4x plus 5. And remember, this plus sign means don't change your signs. So I'm going to drop these underneath. They're like terms. And then I'm simply going to combine them. So 7x squared minus 3x minus 2. And that one's done. This one I'm going to multiply, going to distribute. So I'm going to start here. X times x squared, x cubed. X times 6x, 6x squared. X times negative 1, negative x. Then I'm going to distribute negative 4 times x squared. Negative 4x squared. Negative 4 times positive 6x, negative 24x. Negative 4 times negative 1 is positive 4. So once I combine these, I will have my answer, and that is x cubed plus 2x squared minus 25x plus 4. Real simple one here. We're simply taking x minus 5 and we're squaring it. This is FOIL or double distributive. X times x, x squared. X times negative 5, negative 5x. Negative 5 times x, again, negative 5x. And finally, negative 5 times negative 5, positive 25. I'm going to combine those like terms, which becomes negative 10x. And there I have my answer. Last one, we're subtracting. So I'm just going to write the 5x squared plus 2x minus 6, just like I see it. But then don't forget this minus, it changes all of these signs. So that becomes negative x squared, negative x, positive 2. And then we're going to combine those like terms. So we're left with 4x squared plus x minus 4. Easy stuff. Then we divide, and by dividing here, we're simply using, it's kind of like distributive property, but it's distributive property with division. I'm going to take 2x to the fifth and divide it by 2x squared. I'm also going to take the negative 6x cubed and divide it by 2x squared. And I'm lastly going to take 4x squared and divide it by 2x squared. So here we go. 2 divided by 2 is 1. X cubed divided by x squared is x cubed. Or I'm sorry, I said the answer. I got ahead of myself. X to the fifth divided by x squared is x cubed. So x cubed. Negative 6 divided by 2 is negative 3. X cubed divided by x squared is just x. 4 divided by 2 is positive 2. And the x squareds will cancel each other out. And that's it. That's all you have to do on that problem. Very simple. And then the last one, we're going to divide by that binomial. So as you can see over to the right, I used synthetic division. Remember, I can use synthetic division when I'm dividing by a binomial that has a leading coefficient of 1. And it does not have a squared. It's just x minus 2, okay? So I can put 2 in the box. And then I can take that numerator, which in this case, the 2x cubed is the biggest term, so I start with it. So the coefficient is 2. Then I work my way down, remember? My x squared coefficient is negative 3. My x coefficient, which is missing, I need to insert a 0, all the way down to my constant 8. We're going to bring this 2 down and start multiplying. Here we go. 2 times 2, 4. 4 minus 3, 1. 2 times 1, 2. 0 plus 2, 2. 2 times 2, 4. 8 plus 4 is 12. So remember, I actually took my 2x cubed and divided by x. So naturally, it's gonna wipe that down to x squared. So this first term is x squared, and then x constant remainder. So my answer written as a polynomial is 2x squared plus x plus 2 plus 12 over my original divisor, x minus 2. Hope you find that to be very simple. Let's move along here. As you can see, and this is written wrong, I forgot to change this. This should say 49 and 50. Use that on these two. So I've already answered 50 for you, but look at 49, and then you can see 50. It says a polynomial has functions at negative 4 with a multiplicity of 1. So remember, if it has a multiplicity of 1, it should just be crossing straight through negative 4. So look at the ones that are crossing straight through negative 4. That one's crossing straight through negative 4. This one's not even touching negative 4. There's no way it's that one. We can mark that one out. Is this one crossing negative 4? Sure is. Is this one crossing negative 4? Definitely not. So we've eliminated 2 with that very first 0. The next one says it's got a 0 at negative 1, but a multiplicity of 2. So remember what it does with a multiplicity of 2? It touches it at negative 1. So does this one just touch it at negative 1? No, it crosses it. That's not touching. I mean, yes, I know but it's not hitting it and going the opposite direction. So there's no way it's A. So it's got to be C, right? Well, let's look. Is it coming up, touching it at negative 1, and then going right back down? Absolutely. And of course, as you can see, 2 is the last one with a multiplicity of 1. So it crosses it as well. So my answer here was definitely C. Okay? And you can hopefully reason using those same graphs with number 50. All right. Factoring something that we've done a lot of. We start here with difference of two perfect squares. So hopefully you'll remember that breaks down into two binomials, as you can see above. What multiplies by itself to get 36x squared? 6x. What multiplies by itself to get 25y squared? 5y. And then hopefully you guys remember, or you can check your things above. This breaks down where it's plus and minus. Here you have sum of two perfect cubes. So it will break down into a binomial times a trinomial. What multiplies by itself 3 times to get m cubed? M. What multiplies by itself 3 times to get 64? 4. So hopefully you guys recall in your binomial, you have those original values that multiply by themselves 3 times to get m cubed and 64. But in your trinomial, on your ends, you square those values. M times m, m squared. 4 times 4, 16. And the trinomial has a middle term where you take those two values, like you can see up here and here, and you multiply them. Well, m times 4 is 4m. So the rule is, whatever this sign is, your binomial has to take that same sign, and this first term has to offset it. Now, this will always be positive, as you can see in both of these equations. So there you have it. Very simple. Number 55, we have a 4-term polynomial that we factored by grouping. So here, out of that first group, I can only take out x squared. That leaves me with 2x plus 1. In the second group, remember, whatever this first sign is, I've got to start with it. So it's minus. And 6 and 3 are both divisible by 3. So I can only pull out negative 3. Now, negative 6x divided by negative 3 is positive 2x. And negative 3 divided by negative 3 is positive 1. So sure enough, when we taught this, I told you that this is when you know whether or not it could be factored. If what's left in your binomials are identical, then it was factorable. And our factors are, what did I pull out? X squared minus 3. And what was that shared binomial that was remaining? 2x plus 1. And there you have it. Those are my factors. All right, moving along. Number 57 and 58 ask simply about whether or not it is a factor. Remember, it's a factor if your remainder is 0. If your remainder is anything other than 0, it's not a factor. So what I do is I take this, it's like I set it equal to 0 and solve, and 3 is the number in the box. Now, we always start with our biggest term, x cubed, and its coefficient is 1. Then we work our way down. After x cubed, we have x squared, negative 5. After x squared, we have x, 10. After x, we have our constant, negative 12. Remember, if any term were to have gotten skipped, you would have to include a 0 in that spot. So let's bring down this 1 right here, and let's start combining. 3 times 1, 3. 3 minus 5, negative 2. 3 times negative 2, negative 6. 10 minus 6, 4. 3 times 4, 12. And sure enough, 12 minus 12 is 0. So yes, it is a remainder of 0, and therefore it is a factor. And you can see the one on the right. Same thing. Okay, now we came into rewriting exponents as radicals, radicals as exponents. So hopefully you guys remember, anytime you see a radical, you know that it can be written as an exponent where the exponent is a fraction. So in this fractional exponent, you know that whatever this root is the denominator. The base of this denominator or this exponent is x. And since that 2 is inside, it's the numerator. So this is x to the 2/3. We go the opposite direction. Remember, the denominator of that fractional exponent is the root. So that's 5th root of. And then, of course, a to the 4th goes inside. So very easy in both directions. Remember, this is a multiple choice test. Surely you can pick the right one if you keep that connection clear. The Fractional exponent is a radical. The denominator is the root. Look, the denominator is the root. Easy stuff, okay? Now we're going to solve some equations. So this one, remember, this plus 3 is outside this radical. I need to move it by subtracting. So we're left with the square root of x minus 2 equals 3. Now, how do we get rid of square roots? We square both sides. So I'm left with x minus 2, because that square root and squared canceled. 3 squared equals 9. I'm going to add that 2, so x equals 11. Now remember, you're supposed to go plug that back in. 11 minus 2 is 9. The square root of 9 is 3. 3 plus 3 does equal 6. So sure enough, B is my answer. Okay, you can see the one over there on the right. It's done as well. Moving on to 65. I'm going to first take care of this minus 7. I'm going to add it. So 4 times the cube root of x equals 8. Then I'm going to divide by 4, because that's what it's doing to the cube root of x when it's right next to it. So 8 divided by 4 is 2. Again, how do I get rid of cube root? I cube both sides. It will knock that cube root out, and x will equal 2 cubed. 2 times 2 times 2 is 8. Now go try it. The cube root of 8, sure enough, is 2. 2 times 4 is definitely 8. 8 minus 7 is 1. So yes, 8 is my solution. All right, moving along. We are rolling right along. This may have gone a little faster. Well, we're not quite done. There's some stuff that's going to take a little bit more time at the end. Okay, number 7. Same thing. If you look at this, though, it just has the fourth root, so I need to raise both sides to the power of 4. That will take care of that on the left side. So 2x plus 4 will equal 2 to the fourth, which is 16. And then, of course, I'm going to subtract 4. That gives me a 12. I'm going to divide by 2, and that gives me a 6. Go plug it back in. 2 times 6, 12, plus 4, 16. 4 through 16 is 2. Perfect. C equals 6. Okay, now hopefully you guys recall these consecutive integers and then consecutive even or odd. Please remember these two are very, very much connected. I'll talk about that in a minute. But to do 3 consecutive integers, remember we said it was like 5, 6, 7. Those are consecutive integers. Well, if I don't know what they are, remember we named the first one x. So the next one would be x plus 1, and the next one would be x plus 2. Well, that's exactly what we're going to do for 3 consecutive integers. These 3 consecutive integers, x plus 1 plus x plus 2, have to add to equal 48. So we write the equation and then we solve. Well, there's 1, 2, 3 x's, so 3x. And then, of course, you got plus 1 plus 2, that's plus 3, equals 48. Subtract 3, 45. Divide by 3, x equals 15. So my 3 consecutive integers are 15, 16, and 17. So let's just make sure we answer the question. They ask, hey, which one's the smallest? Well, in this case, that's 15. So in the multiple choice test, they're going to say just that. So make sure you check that and make sure you're answering the correct question, okay? So number 71 and 72. I know that one of them says even and the other says odd. But when we talked about this, we said that you treat them the same way. And here's why. No matter what the first one is, if it's even, let's say it was 4. That makes the next one 6 and the next one 8. Or if it had started and it was 5, odd, the next one would be 7 and the next one would be 9. No matter what, whatever this first one is, it's going to be x. How do I get to the next one? Whether it's even or odd, I add 2. So it'll be x plus 2, x plus 4. So they actually follow the exact same rule. With that being the case, we do them the same way. If it asks me to deal with 3 consecutive even integers, that's x plus 2 plus x plus 4. And in this case, it equals 78. So we have x plus x plus x, which is 3x. But this time we have 2 plus 4, which is 6. So I'm going to subtract 6. That's 72. I'm going to divide by 3. So that's 24. So my my 3 consecutive even integers are 24, 26, and 28. Now, what does the question ask me? It asked me, hey, what's the middle integer? Well, in this case, that's 26. 26. All right, moving along. This one, as you can see, the work done on the right, I want to show you a different way to do this one too. That way you have one where you can see the work, and then you have one where you can see the other way. I can go to my graphing calculator and type these in and find where they cross. So I'm going to check it this way. I'm going to do x squared minus 6x plus 3, and I'm going to do negative 2x plus 3. And remember, if I'm looking for a solution, I'm looking for where they cross each other's paths. So they cross each other's paths in 1, 2 locations. So I told you we could do second, trace, and we could do intersect. That's what we did when we learned this. So I get real close. Actually, it actually showed up on it. So I'm going to push enter, enter, enter. And it looks like one of their intersections is 0, 3. 0, 3. And the other one is down here. So let's do it again. Second, trace, number 5. Let's scroll a little closer to that intersection. That's pretty close. Push enter, enter, enter. And sure enough, the other intersection is 4, negative 5. Now let's go back to our paper. I mean, seriously, which way was faster? Well, no doubt, right? No doubt the graphing calculator is faster. But just know it can be done by setting these equal to each other, getting everything on one side, factoring, solving for your x's, and then taking those x's and plugging it in to find the y's. So I highly assume you guys will use your graphing calculator, come next week or this week when you take your test. Actually, I'm making this on a Sunday, so this week. So number 75 and 76, real simple. You're plugging in the negative 3. Please don't forget when it's negative. When I go plug it in, I've got to put that negative 3 in parentheses before I raise it to any power. That will just ensure that I don't make any mistakes. So I'm just plugging this straight into my calculator. So I'm going to go back to my home screen, open parentheses, negative 3, close parentheses squared, plus 9 times negative 3, plus 12, and it does all the work for me. My answer is negative 6. Okay, let's keep on going here. Actually, did I do something wrong there? 9 times negative 3. Oh, I did. I had the answer wrong or differently on my paper, and here's why. It's not negative 3 squared, you guys. I'm sorry. It's negative 3 cubed. Please forgive me. I'm going to change that real quick, and negative 42 is my answer. I wrote it right on my paper, but when I went and entered it in the computer, in the calculator, I entered it wrong. So negative 42 is my answer. Okay, sorry about that. All right, number 77 and 78. There are a couple of questions on the EOC test, the final exam, that ask you to pick the name that represents a certain polynomial. So you have to decide whether it's constant, linear, quadratic, cubic, quartic, or quintic, and whether or not it's monomial, binomial, trinomial, or polynomial. So there's those. Once again, hopefully you guys recall those, but just know you're going to have a couple questions on here. Now, if you guys remember, or if, like in most of the review, I would do the left side. The right side was the same. It's not in these questions on this last page, so I'm going to do all of these with you. So anyways, we're at about 40 minutes. So hopefully by the time I'm done, this will be about a 50-minute video, which is not as bad as maybe I thought originally. So anyways, here we go. I've got to use, this is operations and compositions of functions is what we learned this lesson. I got to use these functions up here, and then I've got to do whatever these are saying to me. So like here it's saying f plus h of x. So I've got to take my f of x, and I've got to take my h of x, and I've got to add them. No problem. So my f of x is x squared plus 4x minus 12. And I'm adding. So remember, that means I don't change my signs. So that's going to stay positive x, and I'm going to put it under its like term. That's going to stay positive 7. I'm going to put it under its like term. And I'm simply going to combine. So x squared drops. 4x plus 1x drops to 5x. And negative 12 plus 7, or 7 minus 12, is negative 5. And that's the answer. I mean, it's not that hard. It's just a lot of people struggle with these, and hopefully you guys will not, especially it being a multiple choice. So the next one's the same, two functions, but we're subtracting. So if I take f of x once again, that's x squared plus 4x minus 12. But this time, it wants me to subtract h of x. So what does that subtract tell me? It tells me that all of these signs change. So this x turns into minus x, and this 7 turns into minus 7. So now when I combine these, this becomes x squared plus 3x minus 19. Okay? Now, the next one is saying to do h minus g of 3. So when I did this, when I taught you guys this, I said, let's go ahead and do the subtraction first, and then let's insert that number. So I'm going to take my h of x. It was first, x plus 7. And I'm going to subtract my g of x. So remember, this means I'm going to subtract, meaning my signs change. So this 5x squared turns into negative 5x squared. And this minus 2 turns into plus 2. So here's what we're left with, guys. Negative 5x squared. This positive x drops straight down. And 7 plus 2 is plus 9. But what I'm going to do last is I'm going to go back to this final value when I subtract it, and I'm going to insert 3. So h minus g of 3 is negative 5 times 3 squared plus 3 plus 9. I'm simply inserting. So here I go. It's negative 5, open parentheses, 3, close parentheses, squared, plus 3, plus 9, and that equals negative 33. So negative 33 is my answer. All right, there's the answer. I've highlighted it so you could see it. And then the last one is the composition of functions. This one was a little bit harder for you guys. Remember, what that means is you're taking g of x and you're inserting h of x into it. Let me explain. Here's g of x, 5 times x squared minus 2. So instead of going 5 times x squared minus 2, we're inserting our h of x into this x. Okay, that's what compositions of functions are. So what is h of x? Well, h of x is x plus 7. I'm inserting it right in there. So now I'm going to work this problem out, treating that like it's a x plus 7. So with that being the case, I got to square it. So that's x plus 7 times x plus 7. Don't forget the minus 2. So ignore the 5. This becomes x times x squared. X times 7 and 7 times x, that's 7x and 7x, which is 14x. And then 7 times 7, 49. Don't forget that minus 2. Then I'm going to distribute that 5, so that's 5x squared. And then 5 times 14 is positive 70x. And then 5 times 49 is positive 245. And then minus 2. So my final answer is 5x squared plus 70x plus 243. Okay? So composition of functions, what that called. It's pretty fun. Good times. And then that leads us finally down to this last section, which is what we just did. So even though we didn't take a quiz on it in our class, it is on the final exam. So multiple choice, but it is on the final exam. So number 83, hopefully you guys recognize this. This is a recursive rule. See the a sub 1 equals negative 7, and then see how specifically what gives it away is it calls on our previous term. So it wants to know, what are the first 5 terms? Well, you know the first one, right? It's -7. But remember, what we did was, in recursive forms, we said, what am I doing to my previous term? I'm multiplying by 2 and I'm adding 3. That's what I'm doing. Multiplying by 2, adding 3. So that's what I'm going to do. I'm just going to clear this real quick. I'm going to take 2 and multiply by my previous term, -7, and then I'm going to add 3. So my second term is -11. And then we just keep doing the same thing. We multiply that -11 by 2, and we add 3. And that's our third term, -19. To find our fourth term, we multiply by 2, -19, and then we add 3. See, we just keep doing the same thing, -35. And then lastly, we take -35 and we multiply it by 2, and we add 3. Same process over and over again. So -67 is our fifth term. So here are my 5 terms: -7, -11, -19, -35, and -67. Real simple. Okay, number 84 wants me to write an explicit formula. Now, listen, you can check. It is definitely not a common difference. 1/4 minus 1/3 will not keep adding. It's definitely not geometric. Okay, we're writing an explicit formula though. So remember, this is where we had to think. And remember, this is a multiple choice test, which should make it way easier for you. But remember, we had to write equations at the beginning of this when we did intro to sequences, where we had to imagine if the first term is 1 and the second term is 2 and the third term is 3, I got to come up with an equation where if I plugged 1 into the equation, it would give me 1/3. And if I plugged 2 into it, it would give me 1/4. If I plug 3 in, it would give me 1/5. If I plug 4 in, it would give me 1/6. Now, I hope that you're seeing this. It is, and again, it's a multiple choice. Notice how the top is not changing. It's 1, 1, 1, 1. So the numerator is going to be a 1. But look at what the bottom's doing. How do I get 1 to 3? Well, I could add 2. Does 2 plus 2 give me 4? Yeah. Does 3 plus 2 give me 5? Yeah. Does 4 plus 2 give me 6? Yeah. So the bottom is simply taking in and adding 2. Okay? That's not arithmetic. It's not geometric. It's just an explicit formula that we can write that will give me this particular sequence. Number 85, though, wants me to write a recursive formula. So remember, I'm going to name the first term a sub 1 equals 3. And now let's figure out what's going on here. How is this sequence changing? Well, it's pretty easy. Remember, we're talking about how does 3 lead me to 9? How does 9 lead me to 15? It's different than explicit rules. So I could say, well, adding is the easiest way to start. 3 plus what gives me 9? 3 plus 6. Does 9 plus 6 give me 15? Yep. Does 15 plus 6 give me 21? Yeah, this was easy. I'm going to call on my previous term and add 6. So please don't forget, what will I look for that says, hey, this is recursive? You call on your previous term's value, a sub n minus 1. So there you have it, okay? Now, number 86, number 87, and number 88 are all dealing with either your arithmetic or your geometric sequences. So look at this one. I hope that we talked about this enough that you recall I said the only type of sequences that would go back and forth from negative to positive would be geometric. So let's see if this is geometric. Let's see if it has a common ratio. A sub 2, 5, divided by a sub 1, -1. That's -5. Do I keep on multiplying by -5? What's 5 times -5? Yep. What's -25 times -5? Yep, that's it. It is a geometric sequence where the common ratio is -5. So let's find the explicit rule. A sub n equals, remember the rule? A sub 1, -1, times r, -5 to the n minus 1 power. That's my equation. Remember, don't mess with it. Don't touch it. That's it. Leave it alone. So the last thing they want me to do is find a sub 14. So let's go to our calculator. I'm going to clear this off. We do -1 times negative 5, close parenthesis, raised to the 14 minus 1 power. It's a pretty big number. 12207033125. And there it is. Real simple. All right, that's number 86. Number 87. Look at it. What does it look like it's doing? Looks like it's going up. So let's check to see if this is arithmetic. So I'm going to see if it has a common difference. A sub 2, negative 4, minus a sub 1, negative 9. Well, negative 4 plus 9 is positive 5. Is this thing adding 5? Negative 4 plus 5 give me 1? Yep. Does 1 plus 5 give me 6? Yep. So this is definitely arithmetic. So here's my rule. A sub n equals a sub 1 plus n minus 1 times d, 5. Remember I told you let's start by distributing that 5. So 5 times n, 5n. 5 times negative 1, negative 5. Then I told you to finish it off by putting your variable term first, 5n, and then combining your like terms. Negative 9 minus 5 is negative 14. So 5n minus 14 is my equation. So the last thing it asked me to do is to find a sub 9. So we're simply going to go 5 times 9 minus 14. So 5 times 9 minus 14 gives me 31. Okay? And the last one, they give me a sub 2, they give me a sub 6, and it wants me to find the common ratio. So remember, we said that finding the common ratio, originally, when we talked about this, we take our a sub 2 and we divide it by a sub 1. And those are consecutive terms. That's how it gives me r. But I don't have those. So we're going to take our bigger term, a sub 6 value, 768, and we're going to divide it by our smaller term's value, a sub 2, which is 3. And remember the rule, since they're not consecutive like these two are, we have to remember to find r, we got to do how many are in between here. So 6 minus 2 is 4. So I got to multiply r by itself 4 times to give me this value. So to find my solution, I'm going to do the fourth root of 768 over 3. And that will give me my r. So let me show you this. To do the fourth root, we're going to go 4, math, and then we're going to use x root of. Fourth root of, and then I'm going to do 768 divided by 3. And that answer is 4. My common ratio for this last problem is 4. So there you have it, guys. That's 52-minute video. Actually, it's going to be a little more than 53 when it's all said and done. But that is the review for your exam. There will not be a question on the test that didn't come from one of these questions. So study it, prepare, and you should be good to go. Hope you guys are having a good weekend.